So, eh, okay. So let me send this to tuning, and that now, if you don't have a separate workload file, you can always capture those workload by using SQL Profiler, but the end result is just a bunch of SQL queries. Okay, so there's the progress. It does that, and if there's any recommendations, it will show up here. Okay. These are all the existing objects. Okay. Now, this is a standard tool. Okay. Uh, to help you tune if you know what the query that you're running and you're evaluate. This is pretty much an iterative thing, so like an ongoing maintenance if your application is still being developed. Okay, not so much for troubleshooting purpose. Now, above and beyond that, I don't know if you have tried these reports that can help you identify based on your disk usage. So for me, if I'm being presented with a database that doesn't perform very well, and I don't actually know the database very well, the first thing I want to know is, let's go for the low-hanging fruit. Which one is being read the most? Okay. Disk usage by top tables. Which ones are my biggest table? Which resource are being locked with the highest frequency? Okay, so these are all standard report, and they're always pretty much available anywhere. Uh, there. Okay. So this will tell you database by database, not system level things, but very specific database things. You can look at index usage. Okay. And try to identify the tables that has the most resource consumption. And then if I don't already have a workload, I will do a SQL profile with a filter based on that specific object. Okay. So this at least tells you which objects are used most heavily. And also, just as important, which objects are not being used at all. Okay, so because this database hasn't actually really been up and running, it's been dropped all the time, so a lot of these are zeros. Okay, but at least pay attention to what a quick tune is: drop things you don't use. So if it's a non-cluster index, it's not been used for a while. The mere presence means it has to be maintained. The elimination of them means you're going to save a bunch of I/O. Very good question. I hope that you can find
Can I
these.
ask you
Go
about
ahead, please.
can I ask about a different scenario? So you're talking about database optimization mostly, like database level, looking at all the queries that run over time. If we had a scenario where, like in our work, we do a lot of data migration. So oftentimes it's sort of a one-shot deal where a lot of data go from one database to another and it gets massaged, etc. It is important to optimize this since some of these queries run really long. Would you have some, let's say, more hands-on examples or hands-on tips of how to use this? And if I can give an example, I think we've all found out that if I run a join on, let's say, 5 or 6 tables, and if they're larger tables, oftentimes it makes sense to join only two or three, dump them in a hashtag temp table, and then join other tables to that temp table. For some reason, that seems to be faster. Of course, you can index it, but even without indexing that, it oftentimes is faster. Can you explain why that is, for instance, the case? Why is writing to disk and then joining on already a table already is joined on? Why is that faster than joining it all at once? Things like that, or how when I'm writing a script with a lot of transformations,
Well,
how do you make particular decisions to actually make your queries faster?
now
What do I have to look for?
there are a few possibilities without seeing the actual query. There are a few common possibilities. Number one is the possibility of swapping. When you do a join, let's say you have 5 tables. SQL Server will always pick the first table that has the fewest cardinality estimate. Now,
can you explain what cardinality is for
sure,
some of us?
Sure. So, when you say you want to do a 5-table join, now, these 5-table join, each one may have a where clause. Okay. Now, assuming that there is 0 where clause, you're just doing inner join across all 5. How many rows? Cardinalities means how many rows? It's exactly what it means. How many rows? So, it's going to try to use the smallest number of rows as the first stop. The second stop, the third stop, the fourth stop, and the fifth stop. And it's going to pick the join order based on how much each table is likely to produce. So if there is a where clause, and this returns, say, 3 rows, while this one returns 3,000 rows, it's always going to pick 1 to be the first pair. Now the only trouble is the keyword is an estimate. The estimate is only as good as the statistics, and also there are genuine cases where the table is really large and you just don't have enough in the memory to accommodate them. So when you are doing the storing them into a temp table, you are doing your own swapping. So what's in the temporary table doesn't have to be recomputed again. So in other words, you notice in your databases, in your system databases, there's always this temp DB. Okay, this is providing a swap space for large queries that must be sorted and cannot fit in memory. Now, a few things you can look for right off the bat is optimize the I/O on this guy. Okay, now this is one of the things that's sometimes at least in a lot of databases that I come across, very little attention is given to tempdb. For the reason that it looks like tempdb is temporary, nothing important is being stored in there, but it's really nothing could be further from truth. You need this tempdb for temporary tables, and if you decide to use snapshot isolation, okay. Now, another thing that you might have to consider is when you do a table join that involves, say, 5 tables, remember the server has to give you a committed read. If there's any holdup in any of these databases, so a read consistent result cannot be obtained, your query processor will have to wait. Now, it's possible that you can use snapshot isolation Quick question. Uh, okay, I guess a quick demonstration would make sense. So let's say I have the customers. Okay. So this section right now, let's say I decided to update a record. Okay. Now, SQL Server is designed to commit as quickly as possible, so it can release the lock as quickly as possible. So in fact, as soon as I hit that run, it's already committed. Okay. But here's the thing, if you have a really large query, you might wind up having to wait for the resources to be in a state that can provide read consistency. Now, SQL Server by default uses row level locking. So which is waiting for the lock to be released. Okay. Now, if you decide to use snapshot isolation, you will improve your read. So your read will not have to wait for the writer to commit. Okay. Does this sentence make sense, folks? Does this make sense? Or just like I've read this before, it never made sense, it still doesn't make sense. Please let me know. Okay. All right, so let's pick customer ID 5. Does it make sense? Okay, so I'm gonna use update sales.customers. Oops, that's not what I want. Okay, so let's suppose that there is a transaction ongoing. So notice this is luckily where customer ID equal 4. Let's just do that guy. Okay, so that is one row affected, right? Notice if I do a select, customer ID equal 3, no problem. I can see the results, right? No locking, no problem whatsoever. If I want to see 5, no problem. I can see it. But if I want to see 4, now without snapshot isolation, I'm here waiting. I'm waiting because I'm waiting for the lock to be released because someone's making changes. Now, in a highly concurrent system, you really can't get exclusive lock any table, so you wind up having to wait here, wait there, wait here, wait there from time to time. And you can identify these wait by using activity monitor. So if you use activity monitor, it will tell you what is that you are waiting on. Now, waiting is unpleasant, but it will tell you what is that my CLR is blowing up left and right. Huh. This machine is really messed up. Okay, so here is the wait category. Okay. So you see what is your resource being used on the most. Okay. And then within the processes, it's very easy to identify why are we waiting. Now, concurrency is one big issue when you have a big join against the table that's been DML'd concurrently, right? So all those things. So what are we waiting for? There's a key lock. Now, you can mitigate this by employing something called snapshot isolation. A snapshot isolation means if someone is about to update anything, okay, take a snapshot of that data, so the before value of the contact name, and save that into tempdb. And having that in tempdb, I don't have to block anyone, so they don't have to wait until I commit. Okay, they can just go on and get the older version of the data back without blocking them. So make sure you take a look at where your tempdb is stored. You can look at the properties. Okay, make sure it's not competing with your other data files. Okay. So notice by default, it's just going to sit where your SQL Server lives, and it's going to have all kinds of contention with your operating system, all kinds of contention with your other data files. So try to keep it on the RAID 0. Remember, the data inside of this tempdb doesn't have to be durable, so it doesn't have to have any redundancy, but it must be fast, okay, and it must be providing the highest throughput. So that is probably some of the reasons why a large join would work faster with a temporary table, because you already decided that these are some of the first two tables to join without the optimizer having to guess which three to use. Okay. 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 So that's been around for quite some time, and this helps a ton in terms of concurrency. That's all you need to do. At least one of the things that can help you are larger join query without having to wait unnecessarily for a read consistent view. Now, folks, while we're on this subject, right? Read uncommitted should not be an option. Okay, if you see this in your code, find out why you're doing this, because read committed is going to expose you to very difficult to troubleshoot data integrity issues down the road. Okay, so try to read dirty data. That's what read uncommitted does for you. It actually read dirty data, and that's seemingly make things faster. All it's really doing is to not honor any locks that people are holding. So notice I do a begin transaction, right? And if I say set transaction isolation level. So, anyways, while I'm searching for this, what am I doing wrong? Set transaction isolation level. There's no equal. So notice you get one of these things. Cool. All right. So if you do this, and now you don't have to respect anything. Sales.customers. Notice that things are going really fast and nice. No complaints. But here's a problem though. You're winding up reading data that's not real, right? You got the name blah blah, and you go ahead and write a letter to blah blah, and this guy goes, "Oops, I don't mean it." This is a dirty read, right? That read is never read consistent to any point in time. Okay. All right. Breathe for 30 seconds. Breathe, 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 breathe. I need more coffee. All right, so folks, there is another flip side of this, though. I think you mentioned something about moving moving data. I suppose you're talking about like bulk copying things.
Correct. A lot of our work is basically bulk copying between two databases, and it's not just copying. There's quite a bit of data manipulation going on in the middle, and so these kind of deals are usually just one-shot loads that take quite a bit of time. So the problem here is not to optimize tables in of themselves. So creating indexes on these tables, since that may or may not help. In some cases, it helps though. But also, how do I write better queries that are faster? How do I measure whether my query actually is better? So maybe some insights on, let's say, the I/O statistics or the CPU statistics, those kind of. I don't know where you would go.
Sure.
Just throw a couple of things out.
No problem. Now there is a client statistic that you can go for that that will tell you what is the queries profiles. Okay. Now, as far as the timing information on a query by query basis, there are two tools you can use. The first one is called extended events. Now, these extended events can be found under management. Now, the goal of this tool is to help you trap a specific query. Okay. So these are called extended events. If you're new to this, you can create a session that keeps an eye on your T-SQL events. This is a replacement of SQL Profiler. Now, the SQL Profiler can give you timing information on each query calls. Now, here you can go ahead and say here is measure my load, my data load. Okay. You can create a session that says there are already a bunch of templates, so you don't even have to come up with your own. Okay, you can focus on query detail tracking or query weight statistics. So these will then produce things you can, well, we'll see what it is. Okay, so it collects detailed statements and error information. You can use this to track each statement as executed on your system. Now will be on the server side. So this is going to look at how your server is producing data. So in a typical ETL scenario, now I'm going to assume that you're using SSIS as your data flow engine. Okay. Now, beside SSIS, there's also Open Row Set. Okay. By using DB links. Is it called Database Link on SQL Server? I think it's called Database Link. Okay. So now the difference between these two. Quick question: which one do you use? Do you use SSIS or do you use like Open Row Set Database Links?
So typically, typically when we're transforming data, we're just using key SQL statements to go from one table in one database to another. When we're importing data into SQL Server, we'll typically use SSIS via the import-export wizard and ODBC connection.
Well, the reason why SSIS is faster, even at least in my experience, I was a year and a half ago, I was contracted to do something similar, and we discovered that if you're going between servers and you use things like Open Row Set through Database Link, it's actually not very fast. And we realized that what is happening is the server process is actually buffering all the incoming records and transactionally inserting them. While SSIS actually gives you a bulk load option. So Open Row Set is great at reading the data, sure, but when you're inserting the data, you're still limited by your row-by-row transaction speed. The SSIS, on the other hand, has a reader buffer and, well, it can suck in the data while it bulk loads into your database. So it has a bulk write, or when you use a SSIS project, you could choose a SQL Server destination, and there is the default bulk load option, okay, so down at data flow. Do I even have a data flow? Don't have a data flow, but it's not the point. Okay. Okay. So notice there's a bunch of different destinations you can use. ODBC is okay, right? But ODBC is not as fast as OLEDB, right? And the order of speed in terms of destination, okay. This is the fastest. It uses a bulk load interface.
So, well, I mean, just
Go ahead.
to maybe give you more background or to clarify.
Right.
So we'd only really, and we don't necessarily package it. When we're using SSIS, that's mainly for when we are coming from sources outside of SQL Server. So it could be like Oracle,
Right.
Postgres, or any various format. That's why we're using ODBC, because we're leveraging the drivers there. Um, the majority of work that we do and the performance that we're concerned about is when you have, let's say, two SQL databases. You need to write a query to select data, joining multiple tables together and transforming that data and inserting it into another table in another database.
Right.
For something like that, is there a way to use SQL Server, to use SSIS that would be more advantageous than just executing the SQL script?
Absolutely.
In
Absolutely.
other words, okay, so you could take one script from Management Studio and execute it. You can take that exact same query, plug it into an SSIS package,
Correct.
and gain some performance.
Because mainly because the SSIS is designed to perform asynchronous operations. Now let's suppose you have two sets of data, right? These two sets of data has to be joined. It's possible to do in SQL Server to perform the join. Now it's just as well if you read this as an input, read that as an input, and then you can use the SSIS to do your sort and your join. Okay. Now, like I said, there's source and there's destination, right? So what I was going before is in terms of destination. Uh, this part of the transform, if SQL Server can do just as a good job in joining the tables and do all that transformations, um, well, let's put it this way: SSIS is number one, a separate process. So you're not competing with any other user sessions. And also, if you have an SSIS package that reads both tables in or even 5 tables in, okay, and then you do your merge like that. Now, of course, you really have to profile to know the difference in speed, but I'm leaning towards that the fact that if you're using a single insert by select query, everything is single thread, right? And not only that, everything is synchronous. So you have to read everything. So all your records are prepared before you start inserting everything. Now in SSIS, things happen asynchronously. So while this insert is taking place in your destination database through bulk copy interface, your data is coming in at the same time. You have no CPU switching back out to handle your SQL OS calls, because all it's going to do is focus on doing these things at the SSIS runtime. So I tell you flat out, when I first got that project, I was sure that taking data straight from a server and get them right into another server, one query is done, it's quick. I mean, it's easy in terms of writing the insert by select from a distributed query. But at the end, we still decided to go with SIS because it just performs a heck of a lot faster. And for that project, we were also moving data from Oracle database to SQL Server. And we were using OODB for Oracle as our source, and our local SQL Server as the data destination. And I think we were only getting about something less than 10 megabytes per second. Something really, I think we have a 2 gigabyte test database. It would take like an hour to finish. But with SSIs, we were doing like minutes rather than an entire hour. And then it's one of those things that just comes after we just just say, let's build one and profile it and see what happens. And and it turns out that the whole double buffer makes sense. The whole bulk insert also makes sense, because the reason why this thing exists is that your data, it becomes data page rather than individual record that has to be transaction processed. Because a regular transaction process hits your transaction log, hits until you do a commit, and then boom, at some point your database freezes, stops the world, and then the database, the dirty buffer, gets flushed into data files. You bypass all that with the SQL Server destination. You just build in memory data page, and then you do a operating system block copy. So works pretty good.
Victor,
Yes.
talking about the
Sorry.
table or view fast load when you're talking about the bulk insert.
Sorry, can you repeat the question?
Are you talking about the table or view fast load setting when you're talking about the bulk loading?
I'm referring to this bulk load.
Because what we had in our mind, or what I had in my mind, was bulk insert, which is a different concept.
I guess it's probably the same thing. What we mean is we want to insert without logging, right?
Right. Minimal logging. I thought
Right, go ahead.
the only way to do that was either as a select into, where you're creating the table on the fly.
That's when you're that's when you are inside of the database. It's actually a
Can you only use a source that's outside of SQL? Maybe
okay.
That's the trick with SSIS.
Well, the trick with SSIS is an external program. It's using the database interface to do the bulk copy. The same thing that BCP does.
I think the only
yes.
source for bulk insert was flat file. You can actually have various data sources and use bulk insert. That I wasn't aware of that.
Yeah, it's only available as an API, and the only out of the box tool, out of the box without any customization or development, is BCP. But if you're directly,
that's just a Windows program, right? That uses bulk insert.
Right, the bulk copy program is the only program external to SQL Server that actually implement that API. But it is an open API. SSIS implements them as well in the SQL Server destination.
Drivers, sources that you can bulk copy from into the destination.
The API is the destination server level API. So here's an API. Here's your database. Now, the API just populates the data pages. Now, it doesn't really care where the source came from as long as the program prepares an in-memory page that can be copied. So in other words, behind the scene, you're supposed to give the API a pointer to a page. And whatever that page, AK page, is copied directly to the end of the table without going through the SQL OS, which is the transaction processing layer. Right? Now, as far as where the program comes to construct, who construct this buffer is really not this memory page, is not is insignificant. So a BCP reads from a text file, to create those pages that's conforming to SQL Server tables, and the API then simply copy them to the end of the table.
So would you fundamentally need
Right.
to BCP out data and then BCP it in? Or is there a better way of going from one table and bulk inserting it into another? Or is that all defined in your SSIS package?
Yeah, it's inside your SSIS package because reading is reading. There's no, at least I don't think there's a direct path reading in SQL Server. I'm pretty sure reading the data, there's, yeah.
I thought bulk insert can only read from a data file. Or, I don't know. I guess I need to read a little bit.
Yeah, okay, so just so quickly, long story short, so let's imagine you work for Microsoft and you need to write this utility called BCP utility, and the goal is, what is the goal? Right? Between an instance of and a data file in a user specified format. Okay, so okay. Okay. Ah, okay. So let's suppose you do an insert, right? Any sort of insert. There is the whole SQL OS that has to make sure that the insert is written to transaction log first. We call that write ahead logging. Right. And now that's obviously not needed if the source of our data, so in other words, if our database is now the first landing point for this piece of record, there's no reason we need this write ahead logging, right? Because even if we lose the data, the source data is still somewhere else. So to maximize speed, we could read from the file, construct a series of data pages. Now, of course, when I say construct a series of data pages, these are all in memory. And it would be awesome if our destination table can be locked for just a moment. Rather than writing to a log and then flush the data file, we can simply copy this and then unlock this whole table. So we just need one lock rather than these 4 pages at 8K. Let's say let's say there's 400 record in here. Instead of obtaining, release, obtaining, release, obtaining, release, 400 separate DML locks, we can take one table lock, apply them, and basically not having to disturb this guy whose sole job is to process transactions. Does that kind of make sense?
Yeah, So I think implementing this is still the unknown for me at least. Like when you say create pages in memory, like what do you actually mean by that? Like, do you mean
Okay.
are you like what object is containing this data? So like before I was saying like you could BCP
Right.
out, and that's on a memory. Obviously that's on a file on the disk. How would you do that in memory? I guess.
Okay. Let's see if I can find.
Because then the other thing is we deal with large amounts of data that would
Right.
be too much for memory, at least in one particular moment. So I don't know if there was a way of like batching that, or that might be a too low level of a question for right now. But yeah, I'd be curious what that means to create like page files in memory.
Okay.
Or
So
yeah, or
no,
are you saying that SSI does all of that work for you in the background?
that's basically because writing against using Visual Studio to crack open a C++ app or a C# app for the purpose of writing a one-time use bulk copy is a lot of work, and most of the times it's not very maintainable. So that's why SSIS is here to give you a destination. So you could use an OLDB destination, okay, or a SQL Server destination. So you don't have to write your own program against that API.
Yeah, I think it's.
Right.
I just need to get out of my head. I don't know if anybody else on call feels the same way, but it's always been my instinct that if you can do something in T-SQL, that'll be the fastest, most simplest way to do it.
I know that was my idea as well because
Then you scratch your head like, why didn't they make things more optimal in SQL Server? Why do you need to use another program to go around it?
right, because I walked into this consulting gig thinking I was a hero. Because after I reviewed their SSI, I was like, it's too much work. Let me give you this one store procedure, right? And it's awesome. It's going to read the data and insert directly. It's going to be really fast. And it didn't work out where I thought it would. And it turns out because everything's happening synchronously. So all the records are read and transactionally inserted. I couldn't use bulk insert here. So in other words, when I use like distributed queries or open row set, I couldn't use the bulk insert API while I'm in the T-SQL land. And
The other,
yeah, go ahead.
so I guess what naturally, the other question that I'm sure everybody else is thinking that comes out of this is kind of the nature of the ETL that we do here. It's not like a data warehousing environment
Right.
where you have a standard source and a standard destination. We have, throughout the course of a year, we have thousands or at least hundreds of different news sources, and a good percentage of them are going to be a one-time use. Because we take clients from various legacy competing CRM applications, and we migrate them into Bullhorn, and they go live. We don't need to repeat that process. And oftentimes, clients from the same system they're from the identical system, but you couldn't use the same package because they have it configured completely differently, stuff like that. So we've always kind of erred on the side of quick and dirty, and we have the time frames built in to allow for that. So we can do something in SQL that might be 3 hours slower.
Correct.
We have the whole day to run it, so it doesn't make a difference.
Correct.
I was wondering, could we still leverage SSIS and still have that ability to quickly implement these projects without having a big fixed cost of setting up the package. You spend a lot of time setting up an ETL tool.
Correct. Now, that's the dilemma there.
Use it too. Yeah.
Uh, you know what? It's very similar to the case that I had. The only difference is the other client they write these medical softwares, and every hospital sort of customize, and then come times to upgrade, and they actually, believe it or not, some client want to upgrade from Oracle database to SQL. So, and what happened is these things just aren't very repeatable. So, customer A has entirely different result with customer B. So that does happen. Now, like you said, if I need to do this a one-time deal, I would do T-SQL and I would do it real quick. I mean, if if time is not a big issue, it's like I can take a whole weekend off. It doesn't really matter if it's 6 hours versus 1 hour. Then T-SQL is perfectly fine. I mean, I would go for T-SQL any day because you know.
Weighing the time that it takes to develop versus the time it takes to process. But we do have, from that, we can build at least the back end of it
Right.
as being
So the biggest
probably will what we do to SSIS.
right, the biggest gripe with SSIS is that SSIS is a designer tool. So in other words, someone actually has to sit there and design stuff. So to address that, uh, that client I was working with uh, wind up using this called BIML. Have you investigated into that? So what happened is the they okay. So this allows you to programmatically generate SSIS packages. So they might have they have narrowed down the customer into different types. So they wind up producing these BIML scripts. So the packages, the SSIS packages, are not hard coded, but rather they're generated based on parameters. So that gives them a starting point because out of maybe 1,000 tables, 900 will be just working off the bat, and the other 100 tables has to be dealt with somewhat differently. And this allows you to script the packages generation. So the end result is you have a script that can crank out SSIS packages. Yeah, it's a really if you decided to go with the SSIs as your standard starting point, right? It might be worth looking into. Read, watch. So why C sharp? I don't know why C sharp either. Because it's human friendly. Why am I looking at C sharp stuff? But anyways, why is it talking about C sharp? Oh, because I click on C sharp primer. That's the output of the package. All right. So in other words, you can say query data dictionaries. Find me those tables with certain comments in them. So that's my application table. And for each table, does he have this column, this column, this column? If so, do this transform to that destination. And then see if that destination table is there. If not, create it. If so, do the insert. The tooling is quite nice, so you're never really typing this by hand. Okay, so here this is for each this generator for each. So this is the BIMO file, and you use this to generate SSIS packages. Just something for you to look into if it's something you do heavily. Cool. And works out pretty well. It's never going to get you 100%, but it will give you a bunch of packages to start with, and it's a pretty good starting point there. Very cool. Nice. So, by the way, get back to getting back to the extended events. SQL Profiler SQL Profiler looks like this. Okay. Now, the trouble with this tool is a SQL Profiler is an external tool. So when you're doing the trace, you're always bothering SQL Server to say, tell me what you just saw. Tell me what you just saw. Okay, so it's not generated internally from the database, but externally probed constantly. Okay, so when you're running this, anything that happens at server is being captured. Okay, and it's very customizable. And I just realized I have a reporting services running. Okay, so here you'll be able to capture stuff, and you can customize these trace sessions with the event and the column you want to see. Okay, and you can also specify a column filter to say I'm only interested in the specific user. Okay. Only when duration equals or greater than. So if you're looking for things that takes longer than usual, so give me things that's taking more than 500 milliseconds. Okay. Now, this particular event should have a database name, but I'm not capturing them right now. Okay, include them. And say I'm only interested in database name, like T-SQL. Okay, so now I can focus on that specific set of queries that takes super long time, which takes greater than 500 milliseconds, or whatever the time you want to do. Okay, so this is called the SQL Server Profiler, and it's a fantastic tool to, and this is what we always had, okay, to find out what's happening on the server. Okay, so if someone does something that fits the bill, great. I'm so far removed from the planned script. I sort of have to come up with things and see what's in here.
Yeah, sorry.
No worries. No worries. No worries at all. I actually enjoy that more than whatever is planned. So, okay, so the Go 20 would do it 20 times, and I'll see if it captures them. But you'll see that just give me all that queries now. That's the query that's happening. So you can capture those things as it's happening. Okay. Now, once you are able to identify the time period where these interesting things are happening, okay, you can even go as far as look at all the other events. Some of the cool events including things like the entire execution plan. Okay, so here you can say in T-SQL, show columns. There's a plan. Okay, so is it on performance? Parallelism. There you go. So you can say, I would like to see all the plans for those queries and how do they do, along with statistic profiles. Okay, so if you have doubts as to, okay, now I found the queries that is taking a long time, let me capture these statistic profiles. Okay, and this not only shows you the execution plan, okay, but it also includes things like IOs and CPU use. Now, there are two versions of things, so let's just run it. And run this 20 times. Okay, so I'm going to stop this trace. I really should filter by username. Okay. Okay. So each operations, execution plans. Okay. Things that doesn't cost a lot get these really tiny values, estimated rows, estimated IOs. Okay, so for each steps, it takes some time to read it because this is the text version. There's the XML version, which gives you a much easier view. The two things is exactly the same, except this is just pure text. If you want to, impress the people who's watching you, like I want to do right now, like I'm trying to impress all of you who's watching. Like I actually read this, and I don't. I actually use this, and then it gives you that statistic information: operators cost, subtree cost, CPU cost, and each of these estimated number of rows for each of these steps out. Cool. So you can see that there is a merge join, there's a sort, and there is an aggregation. Cool. Now this aggregation is, what is this aggregation trying to do? I'm pretty sure it's trying to get me the top 20 records. No. What is this query trying to do? Oh, that's the top record right here. There's the top 20. And so something's already sorted, but it's trying to compute something. Now that something is trying to compute by grouping by customer ID. Did I lose someone? Did I lose myself? I heard something.
At least you're still there.
All right.
You're still there.
Folks, I'm telling you, man, you talk to the headset for like 2-3 hours a day, right? And you start hearing voices, and you're really afraid to ask people, "Are you hearing that voice?" Because everyone else will be like, "I didn't hear anything," and then you realize that it's just in your head, and then like, I hear voices. Never mind. Okay, so
who are you talking to now? To the voices?
talking to myself most of the times. All right. So, anyways, these are great tools. This is called the SQL Server Profiler. This is awesome. You can capture all this execution information. You can also, this has been replaced by extended events. Now, extended events is based off sessions, and it's the same. It's the same principle. It's the same principle. Get stuff. All right. So off you go. So you can choose a template and say, show me query detail tracking, and boom, blah, bing, blah, boom. The interface is a little different. Okay. And there's a whole bunch more events because this is like everything. Okay. So event library. Okay. Preparing SQL batch starting, SQL transaction. There's a SQL. Let me find things like statistics. Missing column statistics. Not like a million things. So there'll be things like store procedures. Yeah. So the interface is somewhat different, and you can filter by the categories. So if you're only interested in, for example, query executions, okay. SQL statement starting. Where's the SQL statement complete? Oh, it's already selected. Why am I looking at things? Duh, I'm using a template. Duh. All right, so anyways, that's the event that's already been selected, and boom. And again, this is the same set of fields that you want to capture. Okay. The actual SQL text, database username if you're interested. Okay. Database name. And this is the filtering section. And let's find the database. The database name equals tsql. Next. All right, so where do you want to store this? You can just keep them in memory as a ring buffer. Just writes in memory. You can query them in memory and whatnot. Okay. And okay. Or you can write them out to a file later. Yeah. Cool. And you do your finish. And one of the things is scriptable. So you can prepare the event, okay, script it out, and recreate this monitoring session on another server. So if you want some consistencies across servers. All right, so that's that. And you can say start the sessions and watch the event as it happens. Boom. All right, so that's that. Get stuff, and it's doing just that. I'm going to zoom in real quick. The little green play sign means it's currently monitoring. All right. Very cool. All right, so nothing's been captured at the moment, so I suppose I need to run something for it to be captured. All right. I'll leave this for you to have some fun with, but this is how you can monitor what's happening in your server behind the scene over time. Okay, this is under the management section, extended events. Very cool. Now, speaking of, since we're talking, while we're on this subject, right? If you're doing a transformations, SSIS really has some awesome transformation capabilities like pivot on pivot. Okay, you know, turning row level data into column oriented data. Okay, it can do things like scrubbing and cleansing that would otherwise be harder to do in T-SQL. So I think if you're doing a lot of data movement, SSI is definitely something to investigate. All right. Cool. It's 5 o'clock. All right. Making sure I have some time to cover some of this stuff. All right. Cool. Let me just catch a breath. Cool. Now, folks.
For all of that. Those are very useful. Everything we've been really covering about performance.
Oh, my agenda is just get you interested enough so you'll contract with us again soon.
I mean, I'm not going to retain a good percentage of what you've been talking about here, but I know the areas that I need to pointing me in the right direction for understanding what I need to read about more and stuff like that.
That's awesome.
It's hard to retain all of this at once, obviously.
Hey, but you know what? I saved the best thing for last, folks. I saved the best thing for last. Are people leaving? Don't leave me. The best thing's to come. Okay. You know,
Most of us are still here.
no,
Some of us might need to drop off, but
no, because
they've already gotten a lot of value though.
they're on a 3-hour Google Hangout, isn't it? They're probably on the 3-hour limit thing. Okay, yeah, it's if you're using like Skype or Google Hangout, there's like a 3-hour per conversation limit. So I'm pretty sure that's what's happening.
Cisco, the WebEx, right?
Yes, but I'm dialing in using Google Hangout, and it lets me call 3 hours at a time. So
I think maybe we lost Dennis.
I'm sure they're dialing in too. Please dial
Nope, Dennis is still here.
back in.
Oh, this might be a problem with our phone. Because we're all on both the WebEx and our phones.
Right. Actually, I'm about 20 minutes before I get kicked off by Google Hangout too. So it's all right. I'll dial back in. But folks, here's the best part. I'm saving the best part for the last. Okay, so this may not have something immediately to do with performance, but welcome back. Okay, this may not. By the way, it's a good time since we're. If you write that down, right, like the course material and whatnot, is going to be downloaded there, and like the sample code that I'm using, right? This is where the sample code is at. Okay, so just let you know.
Victor, I think we all got kicked off of the meeting, so I think everyone is dialing back in.
No problem. Actually, I am going to do the same as well. Demo/lab codes. So if you have a SQL server, right, and you want to get these demo codes and demo database to run on your system, just follow that link, and it has a URL to download all those things. Folks, I will dial back in about 2 minutes flat because I am experiencing the same thing as the 3-hour limit. So I will be back right away. Just don't panic. Folks, don't panic. I'll be right back.
Welcome to Reservationless Plus conferencing. Enter your conference code, followed by the pound or hash sign. Thank you. If you are the leader, press star now. Please enter your leader PIN, followed by the pound or hash sign. To start or join your conference, press 1. You will now be placed into conference. To mute your line, press star 6. To unmute, press pound 6. After joining the call, to record the conference for those who may miss this call, or for future playback, press star 2.
I am back, folks. I am still here. I'm still kicking. All right. So, folks, now speaking of performance tuning, I just a couple of weeks ago, I was also working on trying to help application perform better. And what I did notice is I'm hearing my own echo. Hello? Okay. So, folks, if you have me on speakerphone, you might want to mute your microphone. Otherwise, I'm sort of, unless I am the person. I hope not. Hello? Okay, sounds better. I hope everyone can still hear me. Okay. Righty then. Okay, so folks, okay. 1, 2, 3, 4. Sounds good. All right. Fantastic. I just realized hearing myself is worse than silent. Something's wrong. How do you guys do it? Okay, never mind. Continue. So, what I didn't notice was there's a lot of application these days. After all, things like nhibernate, which is obviously from Hibernate framework. Okay, that tends to cache a lot. And what happens is sometimes these applications that we are supporting isn't taking the full advantage of some of the things that's already available. For example, things such as calculating a running total, assigning ranks. Okay, so let's imagine here. Here's two stories. Okay, let's say here is a very simple thing. Who is my okay, what is the profit and loss? Profit and loss. For example, what is the YTD sales? What about quarter over quarter? What about a running 3-month average? What about 50 days moving average? And what I did notice is regular expression matching. Regular expression matching. There are most of these things can be done within the SQL Server directly, without having to transport 10 million records in order to compute what is the difference quarter over quarter, or having to write complex store procedure as such. So I'm sure you are familiar with the fact that queries has two scopes, a detailed scope, row by row scope. So when you say select star from employees, every record is a detailed record. It gives you row by row results. And you also have aggregate, which is your group by. Okay. Now in these group by, you're in you're in groups where you no longer have detailed access. Let's say you are grouping by departments. Each group is a given department. Department 10, Department 20, and Department 30. And then you can say for Department 10, what's the average salary? We can do that. What is the sum total of the salary? Who makes the least? Who makes the most? So we can do that with an aggregate group by operation. Okay, so that's straightforward, no problem. Now there is a third option nowadays, analytical queries. Okay, so with that, I want to quickly show you this type of operation, which is detailed in nature. Okay, it's almost like a detail record. This is on chapter 13, so if you want to follow along, okay, open up the demo on module 13 in the demo files. So I'm going to run this administrator. The setup command, right click, run this administrator. Now the goal of this section is to tell you what are some of the SQL functions that can potentially save you a lot of server round trips, or minimize some of the query that otherwise is very, I suppose, difficult to write. Okay. Okay. So here we go. This is 13, right? Okay. So first, we're going to create a view. Notice this create view. Just give us a view to start working with the sample data. Okay. So this view called sales category quarter year. Okay. This is not what I'm trying to show you. This is just the query that the view that we're going to use to practice these analytic queries. Okay. Now I'm going to quickly change this result by adding an order by. So for the same year, I want to then order by category. Category. Okay. It's just good habits to make sure they're lined up. All right, so I can see the order year based on category, right? No problem. And I think there's one more column. Quantity. Now, if you remember learning about T-SQL cursor, okay, this is a textbook example of using a cursor. You open a cursor for this select statement, and you start adding quantity up. And you insert the result into a temp table, and then at the end, you select from the temp table in order to get a running total. Okay, so I want to show you real quick how this can be done using the analytic function called sum of quantity. You're thinking, wait a minute, where's your group by? There's no group by on this guy. Over order by order year. I'm just going to actually order by the same thing so it makes sense. Okay. Now this is a function that applies at the detail level. Okay, I guess this result alone is hard to see, so I'm going to add QTY right next to it so you can sort of follow along what's happening. Okay, so you notice the first row, there's nothing to add. That is the running total. That is the running total. And that is up to here. Okay. Now you could also do an average just as easy. And that will be an average as it goes. So it's a running average of all the record up to that point. Now this is pretty cool. Now what is even cooler is that I can use a keyword called partition by. Now it's good for me to check with you. Do you use this already? Or is this sort of like, whoa, I didn't know SQL Server can do that? Category. Ah. Fantastic. Okay. I'm just hoping this is somewhat still interesting, not something that you sound check. Mary had a little lamp. I just made everybody mute themselves because of the echo issue.
Yeah,
Go ahead.
Partition by basically resets the sum. Start summing again.
Bingo!
The group changes.
Bingo, you noticed. Exactly, that's what that does exactly. So it partitions, that, in other words, it resets whenever there's a new year. Cool. All right. And there are other cool functions. First, and I'm just going to copy everything except the last comma. First, okay, this is horrible. Whenever you're arguing with like SQL developer, like, thank you for correcting me, but this is first value. So here is your partition. Oh, my eyes are fooling me. So that's my entire partition. So that function always returns the first value. Okay, so that's pretty cool because you can take that first value and then you can find out the differences between the current value, right? So you can say QTY minus first value of that partition, and now you get the differences. Okay, so you can see that is 962 is 880 less. 1357 is 485 less. So if every one of these value is the end of day balance, you can say this is month to date profit and loss. So you can use this to quickly calculate things that would otherwise take a cursor to calculate. It's much more work. All right. So this is collectively called analytic function. A lot of them share the same name with an aggregate function. So try not to get confused between the two. Analytic functions working with partitions and windows and order by and so on. Okay, and here is the complete list of analytic functions. I was sure there's more than that. Okay. So let's see what else we can do with this. Now this is a rank. Why isn't it in the analytic function list? I don't know. But okay. Just make sure you create a view to support this example here. So another thing that you might commonly want to do is be able to rank things. Okay, so here is a column called rank over. So that rank over, we're ranking over order by unit price descending order. So here, we're not partitioning anything. We certainly can, right? We can send rank over order by, and we can say partition by category ID. Then it's just natural that we order by cat ID as well, so we can at least visualize the result. The result won't be too confusing. All right, because we're partitioned by cat ID, every time there's a new cat ID, price rank 1 through 12. 1 through 12. It's awesome. And you'll notice that there are a bunch of guys that has the same value, right? So we skip rank 5, 6, 7. So if you rather have 5, 6, and 7, you can just use dense underscore rank. Bam. All right. So notice this way it doesn't omit any rank number, so it keeps everything tightly compacted. Okay. All right. But there's got to be more to this, right? So we got that guy. Category, quantity. Okay. Okay. So here is the query, right? Let's see if I have the other one. Okay. Now, let's Creates a view. Rank over that. Ah, that's the query I want. Except I don't have that view. Sales, customer orders. This is the view I need. What? Wait, where's the view I need? Yeah, when in doubt, just run the whole script. It will recreate everything you need. And much better. Excuse me. All right, so here we have customer ID. We have, as you can see, these are ordered a month, right? So customer ID, order month, customer ID 2. All right, so let's say we want an average, okay, of prior, current, and next. So in other words, 17, I would like to have a new column right here that is the average of these three values. And for this cell, I would like to have an average of those three values. Okay, so we call this moving average, right? So here I can add a new column. But rather than sum, I'm going to do an average. But without the frame, it's going to average everything. Okay, it becomes a running average, and it's going to average everything. And not exactly what I want. So notice how it averages everything. Okay. So here, order by, order month. That's what I want. Order month. And it's already partitioned. Actually, just realized partition shows up before the order by. So now I can restrict by using rows between 1 Okay, so it's rows between 1 leading and 1 following. I think I got this right. No, I didn't. What is a keyword? With 1, oh, preceding. 1 leading. Duh. Preceding. I knew when it didn't show up the right color. Like, why was I thinking leading? No idea. All right, so here, my this column is evaluated against 1 preceding and 1 following, and the average is taken of the 3. Very cool. And notice this is smart. Okay, if there's no prior value, notice this 39, right? Notice how there's no prior value. It's smart enough to say don't divide by 3, divide by 2. So it took 38 and 41 and divide by 2, and you get 39. So this thing's pretty smart. Now I'll give you a moving window of 3 days or 3 months. It's pretty cool. All right. And you can also create a three-month moving average. Okay. Now you can also say month over month. Okay. You can say lead and lag. That's what these two things do. Lead and lag. Okay. So here I can say, give me the lag value, lag of 1, oops, lag of quantity, and I'm going to do the same thing pretty much. Okay. All right, check this out, check this out. So it's going to look at the prior value. So notice this came from the lagging row. So 41 came from the lagging quantity, right? So you can do a month over month. Just simply take QTY minus. And that's month over month gross or contract. Okay, so there's a 3 minus 24. Now this will help you supply data to an Excel client without your Excel client issue like 50 queries, because it's convenient for the Excel tool to drag and drop fields, filtering, aggregates. But behind the scene, Excel doesn't run these queries to produce a result. It runs straight away, select all of them, and do every calculation within the Excel memory space. And it is one of those things that if you know it's there, you can then present them as a view. Okay, and then you can plot this right out to an Excel chart without having to incur too much overhead. All right, so that's the windowing, offset, and framing analytic functions. All right, time to take some questions, folks. Questions? Oh, I forgot the end tile. Got lag, lead, all that stuff. Cool. I'm checking the chat window. I use the row number quite a bit. Oh yeah, it's awesome, right? It's good. It labels each row as they come back. So pretty good stuff. Okay. Yeah, nth tile is just, break down the data into percentiles and rank them. Just assign them, I suppose. So here, we'll say n tile. And rather than typing it, just going to copy and paste that expression, and it works just well. Is that right? Something doesn't look right. Oh, I guess let's break down to 5 possible values, right? So all right, so it breaks down all the records into 5 equal parts and give them each an nth tile assignment. All right. Now, any questions about this, folks? going to have a 30-second breather and see if anyone has any question coming up. Don't forget to use chat. If I don't respond to your voice, you might be muted, but feel free to use the chat window. All right. So that one bites the dust. Another one bite the dust. Okay, so pivot and grouping sets. Okay. Now this one's fairly short. I want to reserve like a 15 minutes at the end. So let me just run through the pivots and grouping set. It's simple enough. By the way, pivot and grouping sets, again, we typically do this so that folks who uses Excel or reporting services can quickly consume the result without having to pull all of these detailed data into the Excel world in order to make sense of those information. So not a very good thing. All right. Cool. So let's give this a shot. All right, so this is on pivoting in module 14 it is. Module 14. Okay. Boom, boom. Don't forget to run as administrator for the setup.cmd. Okay. So folks, this is 14. So this is going to go ahead and create a view, right? Called category, quarter, year. So from this view, here's our resulting data. Okay. Now, folks, one thing I've learned for some reason is working with those other folks, right? For some reason, for one reason or another, they enjoy consuming data in a column-oriented fashion. So that means when you supply the data to Excel, folks like to see data like this: 2006, 2007, and 2008. And then you have this internal monologue, right? You have this internal conversation with yourself and go, what? You want me to create a new column every December 31st in order to support your query? So while I'm enjoying my New Year activity, I have to come here and alter table? Really? That's how you want your life to be? An ever-growing column? Okay, so anyways, we would like to store our data this way because, row sets are easy to sum, min, max, average, aggregate, and so on. So much easier to do just that, right? But we are typically asked to turn it into that fashion because Excel looks better. And because English is a language, reads sideways, right? I bet you if like Chinese is a standard of data analysis, we just read top down, right to left. Got no problem with that. Okay, so anyways, so here's a query that magically, bam, turns everything into a column-oriented fashion. All right, so where's the magic? The magic is a keyword pivot. when we turn the table from a row level orientation to a column, okay, ignore this. Okay, just focus on your that's just your source table. So you don't really need to look at it too much. Okay, this is when we turn the details into column oriented. We're grouping by having year equal 2006, grouping by 2007, grouping by 2008. Okay. All right, so here we have it, and this is how we want to turn our row into column. And be mindful, you're going to lose details. Okay, so here is the detail before the pivot. Okay, so notice we have at least two separate rows that I can see, right? 9, 40, 35. Now, I am essentially grouping by 2006. Grouping by 2006. And I'm taking a sum of the quantity. Okay. Now, you don't have to use a sum, but it has to be an aggregate function. So an average would work as well. So this would pivot and aggregate on average. Okay. So now that becomes average. So that's pivoting. Now, unpivoting is the opposite. Now, you find unpivoting quite common, especially if someone throws you a CSV file with like growing columns, or you're subscribing to some data feed, and the data feed decide to give you a column-oriented data, and you just need to do some kind of statistic things to it afterwards. So here is what your table looks like when you import them. Why do we import this way? Because import wizard is awesome. Right click, import data. Here's a table. I want all the columns. Bam, 3 columns. Good. Now the next step is to unpivot them. Okay, so here, this creates an unpivot. So that means for every category, okay, we're going to turn it into 2006, 2002. So every category will now have 3 rows. And now it will be a row-oriented result set. Okay, so 3 rows for beverage, 1 for each year. All right, so that is pivoting and unpivoting. Incidentally, the SSIS can do just the same. Pivot and unpivot. Cool. All right. Okay. The next part is called grouping sets. Grouping set is about answering for all the possible questions that can be asked. Okay. You're probably thinking, wait a minute, isn't that what cubes do? That's exactly what cubes do. So here is the category sales. Okay. All right, so here is one query that says group by category. Okay, so this gives you the sum total across all customers. So a category across all customers, condiment across all customers, confection across all customers. Okay, and group by customer. So customer across all category, customer 1, 2, 3, 4. Now this gives you a grand total. Okay, so rather than writing 3 separate queries, which then allows them to slice and dice using Excel tools, right? We can just say grouping sets, which essentially says group by category, union all, group by customer. So here's a keyword group by, grouping sets. Bam. All right, so that is your grouping sets. That's across everything. That's customer across category, category across customers. All right. Now, which is, notice this is 9 rows. Okay. That's grouping set. Okay. That's 9 rows of data. Now here, we're going to use the group by cube. Okay. Group by cube is interesting. Okay. You might have heard of OLAP cube. Okay. The result that's stored in the cube came from this type of query, where we do a group by cube. Now this group by cube, in addition to the aggregates, okay, it also group by beverage and customer. So it adds this records here. Now this result will answer any questions you have against category and customer. For example, I want to know customer 3 across all the categories. Here's your answer. I want to know condiments across all customers. That's the answer. I want specifically customer 3 with confection. It's there. So usually you can create an indexed view using this kind of cube in order to materialize all the possible answers against these 2 dimensions. So in this cube, this is the measure. This is what we call the measure, and these are the dimensions. There's no hierarchies here, at least in the data warehouse scenario. There's no hierarchies here, but these are certainly dimensions. Okay, so with the cube command, you'll be able to get every intersection of these dimension members. Now working with rollup is exactly the same as cube, except it only goes up one direction. It will roll customer into category, but not the other way around. Okay, so the result can answer, for example, for condiments across all customers. But you are not going to see customer 1 across all categories. Okay, it's not being aggregated in that direction. So notice the roll up, only roll up from right to left. So customer rolls into category, but not the other way around. Whew. Step 7, the group ID just tells you whether or not that row aggregates on category. So it's a 0 and 1 value. So that says this row aggregates on category. That's why that's null. Okay, so it tells you that the reason for this null is because it's grouping on that, but not grouping on that. Okay. All right. Fantastic. Any questions so far, folks? Okay, I'm dragging this material. This is the same soft copy of the book you want. Okay, so this is the section about query performance. Yay, exciting stuff. All right. So here, some of the factors that can affect your query performance. Okay. I think obvious the low hanging fruit is don't select columns you don't need, right? Avoid star. Why? Because carrying these additional data is costly. Use a where clause to filter as much as you possibly can. Now, if your table is partitioned on your where predicate, right, the where clause can filter out parts of the tables. So rather than scanning 2 billion rows, you can look at just, a part of the 2 billion. Okay, now always avoid expressions that manipulate columns in the predicate. Okay, what we mean by that is there are two problems with this type of approach. Okay, when you do date diff, just looking at it's no big deal. It gets the job done. Okay, but be careful because your server, if you think like a machine or think like a SQL server, notice the only way you can evaluate this is to apply that on every single column to find out the difference in years between what's stored. So in other words, if I have 10 million rows, this date diff has to run 10 million times. Now compare with that higher date less than equal to. The higher date doesn't need to change. It's this function. This function is deterministic, somewhat. Okay, it's not this deterministic if it runs for like 3 days, but the fact is, as long as the date doesn't change, this is like what value that you can use this to fast seek. You can use the index to actually seek this stuff. You can't really use index much here. You still have to read row by row. So top query, not so good. Bottom query makes more sense. Okay. Now the quick rule of thumb is keep your comparison in the same data type as your column. Okay, so remember your higher date is a date. So make sure you compare it to a date. You're good. Notice this, your higher date is a date. What are you comparing to is a number. Bamboo. Try not to do that. All right, minimize the use of temporary table or table variable in your queries. Okay. Minimize the use of temporary table because a lot of databases do not tune for temporary tables. Okay, and swapping to disk is just not cool. Speaking of swapping to disk, right? If you're using SQL Server 2014, this is something that you might want to experiment. Called buffer pool extension. Now, the buffer pool extension is a feature in SQL 2014 that allows you to use. What? What does that have to do with buffer pool extensions? Okay, so this is all you need to do. It's a simple configuration and you're done. Okay, set buffer pool extension on. The caveat is you might have 256 gig of RAM, right? And you need more than that. Great. You can extend it to a file. Fine, not 256 RAM. Let's say you have 32 gigs of RAM. Now, remember, when your buffer pool is filled, things have to be swapped out to disk. If you have an SSD, before it falls out to the disk, you can keep them in your SSD. So this is just an advancement in our disk technology that increases your buffer pool. That's how much you can cache in your memory. Okay, so that's one. And the other one is memory optimized tables in SQL 2014. That's another very cool and useful feature. Okay, which allows you to say this table should be pinned in memory. Okay, so that's another one of the ways you can trade off memory with I/O. Okay, So this allows you to not having to deal with. Oh, look at that. He has almost the same icons that I do. But I have more though. Huh. Okay, so but anyways, what's the point? Okay, so notice that because everything's in memory, things can be designed differently. If you really want to know how this memory optimized table works, there's some blog, but the actual implementation is fairly straightforward. Okay. You add a file group that says all the tables that I create in this file group should be memory optimized. So the table that you create, okay, had to be nominated to be memory optimized on. Okay. All right. So essentially, all the operation against the table will now be completely stored in memory without all that disk I/O. Again. Okay. So it's pretty cool things. And if you're thinking that's new, it's really not new. Oracle has been using that for a while. In Oracle, it's called times 10. Okay, it's the same. It's almost exact same design. All right, I got 3 more minutes. If you have, if you're working with developers and etc., there is some other type of data storage that you might want to consider. Things like embedded database, etc. That may allow you to take some of your data off of your SQL Server and keep them with your application without incurring a ton of overheads. Okay, folks, question time. Wow, how's your ear not burning? Okay, folks. If you have any questions, feel free to send questions my way. Okay. My email is victor@objectmage.com. Yeah, that's about it. Answering time, folks. Time for answerings. Any questions, folks? Anybody still on?
We're here.
Folks, open mic, take it away. Any questions in your mind? All right, folks, ask away. I think it's only two of us.
Well, Victor,
yes, go ahead.
Great presentation. Thank you very much.
You're welcome. I just hopefully I was able to provide you with some useful information that you can, well, write into problem and email me with problems you may have. All right. I think in your meeting invite has all my info. So, Jen, do you want to jump in and let everyone know what's after the session? Okay. I think I'm on my own here, folks. Oh, okay. All right, folks. You're welcome, folks. If you have any questions, please let me know. Yeah, it's, I'd rather stay on this session because if I hang up right now, I have to go downstairs help my son with his homework, and I don't know what to do, man. The other day, the teacher gives him 5 words to make sentences. It was spring, summer, fall, winter, and season. So he made the following sentence: Spring is not my favorite season. Summer is not my favorite season. Fall is not my favorite season. Winter is my favorite season. I'm like, I can't correct him because I think in America you're not supposed to correct them. You're just supposed to say good job or something. But I'm like, I was like, creative. Oh well.
So what else would you have said?
I was
Otherwise,
I,
correct him.
I was hoping he would write something more, cohesive. He's 7 year old, so like something like, spring the flower blooms and something like something.
I think you can encourage him. But then again, I actually am American. I was about to say I'm not American, but I am. So,
Oh well. All right, folks. It has been a pleasure, and I had a great time, and I hope you do the same.
okay, well, sure will. Thank you for the presentation, and I guess good luck. We'll stay in touch.
All right. All right, folks. Have a
Okay.
good evening.